Hello, everyone. Welcome to the second talk of the evening. If you were here for the last talk, you got a nice overview of the Psychological Science Accelerator. And now we're going to be talking about increasing trust in science. I'm really happy to introduce my friend and longtime collaborator, Dr. Christopher Chartier, Associate Professor of Psychology at Ashland University and the founder of the Psychological Science Accelerator, which is a multinational network of 1,400 research laboratories from across 70 countries that are engaging in big team open science projects. On a personal level, one of the things that I value most about Dr. Chartier is that throughout his commitment to improving the rigor of psychological science, he's maintained his commitment to kindness and collaboration. So without further ado, here's Dr. Chartier talking about increasing trust in science by increasing the trustworthiness of science.
Cool. Thank you for that really nice introduction, and thanks for giving me the opportunity to speak to this group and this campus community. I assume that there's like some overlap in attendance. The talks are independent, but there's going to be a little bit of overlap in content, so my apologies on a couple elements that I'll kind of reiterate or repeat. But welcome to folks that are here for the second talk, but not the first. The talk is Nullius and Verba. This is the Royal Society's original motto that essentially means take no one's word for it, or essentially like that, this basically this charge or this motivation or suggestion that in our scientific products, there should be mechanisms by which other parties can verify our findings and kind of build trust and the trustworthiness in our scientific products. As was the case in the last talk, I just wanted to reiterate that I really kind of enjoy interruptions. If you have a question as we're going, feel free to pop that in the chat. I'll kind of keep an eye on it as we go. And then maybe if it's stuff that you want to wait for the end, I'm going to reserve some Q&A time towards the end of our hour here. Maybe that goes in the one that's explicitly called Q&A. That might work out kind of well. Okay, yeah, so in this talk, I'm going to zoom out a little bit to think about science more generally and perhaps focus more on the social sciences than just being focused a little more narrowly on psychological science. Of course, there will be some overlap there though. And I'm going to focus on how we can improve public trust in science, essentially by improving the actual trustworthiness of the science that we conduct. And so we'll talk about some kind of reform interventions and some cool new changes and new activities in that regard. I do want to start with some just kind of public perception data that I kind of always am interested in. I've been digging into. So I'm going to start with a few data points from the Pew Research Center relatively recently. Some of these data are from 2019, some are from a little bit more recently. Okay, so how are scientists doing in terms of the public having confidence in them or trust in them? I guess the good kind of headline news is that we're doing relatively well, at least compared to these widely maligned and not highly trusted groups. So who beats us out? Typically the military. People have more confidence that the military is acting in the public interest. But scientists do hold a higher level of trust or confidence than religious leaders generally, the news media, business leaders, and elected officials are kind of bringing up the rear, which is an interesting commentary on public life in general, I suppose. But of course, trust is critical in science in terms of there being public buy-in for our results. We're seeing this dramatically, of course, during the pandemic and people's perceptions to evidence and published results around masks, vaccines, or other health interventions. It's really critical that people do have trust in science, and it's critical that the science is trustworthy and worthy of their trust, of course. Just to kind of put these data in a slightly different visual lens before we kind of dive into some of the other content. The scientific community's trust has been holding pretty steady. This is the highly agree version of the question, essentially. And so, like I said, lagging behind the military, but higher than some other kind of institutions. One interesting data point is that this is somewhat moderated by political beliefs or political affiliation. So it's important to kind of keep in mind that the US public isn't a monolith in terms of its view towards scientists influencing policy or taking an active role in kind of policy issues. So folks who are more Democrats or lean Democratic are more inclined to agree that scientists should take these active roles, and that compared to other folks in the population, that they are more expert and better able to make these decisions. And so again, that has implications for the public's consumption of our work, and for how we're able to kind of implement policy suggestions, or how receptive people are to the findings that we share, not just in psychological science or the social sciences, but science more generally. So I wanted to start with that to kind of provide a little context that even though compared to some other institutions, you could say science is doing relatively well, even on recent data, there's always room for improvement, and increased trust in the scientific process and our findings is going to be better for everyone. So we can look at ways to kind of increase it. We haven't always been perfectly worthy of the trust of the public, particularly in my own home field of psychology. It pains me to start here, but just as I did last hour, I need to give a brief overview of psychology's so-called replication crisis. As we look to try to replicate high profile and influential published findings in the scientific literature in psychological science, we often fail to be able to successfully replicate studies. So in one kind of large attempt to replicate 100 studies, only around 40 successfully replicated. That means you go to the same experiment again, and you get the same result in the same direction again. So if replication rates were perfect, all these dots would be blue and they would be on the diagonal. As you can see, that is like quite clearly and quite dramatically not the case. So in my home field of psychology, there's cause for concern and perhaps reasonable cause for lack of trust in some of our published findings. That's kind of the zoomed out view in psychology. I wanted to zoom in a little more on kind of one interesting and illustrative literature area on this concept of ego depletion. Ego depletion is this idea that we have cognitive resources that can be depleted, and that might make us less able to show willpower or stand up to something tempting subsequent to being depleted or being cognitively exhausted. So in some of the kind of fun studies in ego depletion, they'll like have participants come to the lab and bake delicious, soft, gooey chocolate chip cookies, but ask them not to eat them when left alone with the cookies, and instead eat radishes. And then they'll subsequently put them through demanding cognitive tasks and look for a depletion effect. One interesting thing is that you can look at the published literature, and a relatively recent meta-analysis of ego depletion found overall a medium-sized effect across operationalization, showing like a pretty large and robust literature out there. But a high-profile and rigorously conducted replication attempt with thousands of participants that really attempted to look at this one operationalization essentially found no effect. And so I also color-coded this. The meta-analysis is like the cookies. As psychologists, we like that. Oh, that's cool. We've got a fun finding. And then over here in red, the failed replication attempt I'm likening to the radishes. It's like the vegetables we need to eat for the health of our science. I just kind of was tickled by that little thought as I was making this. But that's a head scratcher, right? That you can have this large published sub-literature, and at the same time really struggle when you do go to attempt pre-registered rigorous replications to replicate findings. This, as I promised at the start of the talk, is not just a problem in psychology or the social sciences. This is a critical issue and problem in the physical sciences as well, perhaps in no more important a domain than cancer biology. So when we look at some preclinical replication work done by, I'm going to look at a couple companies' work here, starting with Bayer. They attempted to replicate in 2011, they published these findings, 47 exciting published preclinical cancer biology studies. And of course, they'd like to find cool new drugs and interventions to fight cancer. Oh, I'm sorry, I got my cursor off there. There we go. And they succeeded on less than a quarter of those replication attempts. I guess you'd say even worse on a scorecard than the large psychology replication effort. Amgen, another kind of leader in the cancer drug domain, conducted a relatively similar study around the same time, where they termed them landmark preclinical cancer biology papers. They looked at 53 specific findings, and they were only able to succeed on less than 15% of those promising or landmark preclinical cancer biology findings. So if the cookies and radishes thing doesn't convince you it's important, and I understand if it doesn't, although I'm a proud psychologist and I think that our science is important in people's lives, I think there's no better example than looking at replication problems in cancer biology to draw a straight line to the impact on human lives and why we need to increase the trustworthiness and the replication rates of our scientific products. So it's not just a psychology issue. This is also demonstrated if you just ask researchers about different maybe measures of there being maybe a replication crisis or reasonable lack of trust in our own work or in the work of our peers. Just a straight up question in a survey conducted and published in Nature magazine showed that a majority of scientists do think that there's a crisis of some sort in this kind of replication, reproducibility, suboptimal replication space. And then more specifically, many researchers can share stories or personal experiences of attempting to replicate work, either their own or others, and failing to do so at relatively large rates, or this is a relatively consistent experience. Some amount of that, of course, is normal, good, and healthy in science, but when you have replication rates below 50%, below 25, below 15, I think we can all agree that that's relatively problematic and perhaps a reasonable cause for shaky trust in scientific publications and findings. And this is reflected also when you ask the researchers themselves. Okay, so just as I did an hour ago, we can look at, but I'm going to dive deeper on this, some ways that the hypothetico-deductive model of science breaks down, at least in psychology and likely in some of these other empirical fields, leading to some of these low replication rates, and in turn, perhaps a lack of trust in scientific published findings. So I'm going to zoom in on a few of these little red bad words here in this talk. Particularly, I want to talk about small samples, publication bias, harking, and p-hacking. So we've got our kind of classic model of how science works, but then in red, there are some kind of things we can highlight that suggest those low replication rates are driven by relatively specific and kind of predictable suboptimal practices and how we actually go and do our science that falls short of this kind of idealized version of the hypothetico-deductive model. Okay, so let's get into some of those specifics, and then we'll have some brighter stuff later, some more optimistic improvement stuff. But I do think it's kind of fun to look at some of the problems. I and many others think that one of the big engines of a distorted, a warped, published literature, one that can be difficult to replicate when you go and conduct a replication, like really the engine that drives a lot of this is publication bias. This is the idea that it's difficult to publish in a peer-reviewed journal a finding that is null or that doesn't show a statistically significant effect in the direction of your hypothesis or prediction. That's problematic if there's this bias in our publication practices, because it suggests that the published literature is not realistic and doesn't reflect the actual whole scale of findings that are out there. Many end up, it's called the file drawer effect, just in a file drawer if there's a null result. And John Oliver had a great little bit on this a few years ago that I love, and I just think demonstrates this so well. It would be very difficult in the current publication ecosystem to publish a study with the title "Nothing Up with Acai Berries." And essentially what he's suggesting here is, as scientists, we're drawn to positive results. Consumers of our science are drawn to positive results, and we want to publish and we want to read and see the paper that says, wow, acai berries improve cognitive performance, or acai berries reduce dementia, or whatever the case may be. A bowl of acai berries is equivalent to running a half marathon in terms of your cardiovascular health or whatever the case may be. Of course, the problem is if there are a bunch of studies where the genuine finding is nothing up with acai berries, that's important to know. It suggests that perhaps there aren't strong health benefits of one of these proclaimed superfoods. If only the one study that shows an interesting statistically significant finding for acai berries is published, then we get this warped, distorted published record of what's actually going on in our studies. And his bit, if you want to YouTube it, is far more entertaining, although it's not, it's PG-13 or more, so just wade in carefully. Adult language is used heavily because he's on the late night circuit. Okay, another kind of major problem that reduces the actual trustworthiness of our findings and therefore the trust that folks might have in the published literature is this idea of low statistical power or running small studies, particularly then when they result in a flashy positive finding. You might be able to publish that, but it might not give a realistic view of a phenomenon or an area of research. So Simmons and colleagues did this really cool demonstration, or in one of their papers they showed kind of a common rule of thumb back in the day in psychological science was make sure you get at least 20 participants per cell of a design or per condition of a design. Anything less than that is probably too small to draw conclusions from. And we see a lot of very small end designs published also in like exercise science or in some areas of health sciences that are potentially problematic. So as a way of demonstration for why this might be problematic, let's look at a few things that you can, in fact, reliably detect or consistently find or discover in a statistically significant manner with 20 per cell, with your sample of 20 per condition. You can, in fact, consistently demonstrate that men are taller than women. That's good. There's something that we know is true on average, not universally, of course, but that we can reliably detect or find in a small sample. So this is kind of giving us some context for how big our samples should be in our studies. People above the median age are reporting that they're closer to retirement. Again, these are kind of like obvious findings, but they're just kind of making the point or setting the stage. Women report owning more pairs of shoes than do men. This is absolutely not true in my household. I am the shoe hoarder in our household, but that's a stereotype and something you can consistently find in actuality, in fact, in relatively small samples. Okay, but what are some other things that actually seem quite obvious that you can't reliably detect at 20 per cell or less? Just as kind of a benchmark for when you see a study that suggests, hey, in these 20 people per group, we found out that acai berries improve this health outcome. So this is something just kind of keep in the back of your mind to gauge effect sizes and reliability or robustness of findings. So that is not enough participants, or that's not enough statistical power or a large enough sample to consistently find that people who like spicy food are more likely to like Indian food. You actually need more participants than 20 to find that. The obvious finding, I would say that liberals rate social equality is more important than do conservatives. It's like a central theme of that kind of political debate. You actually need a moderate number of participants to reliably detect that. Moving away from height and instead weight across sex, men weigh more than women, 46 per cell. And that people who like eggs report eating egg salad more than folks who don't report that. Again, you need larger samples for that. Okay, so it just sets the context, and I just find these facts entertaining and illustrative. And as a consumer of science, it's maybe a good set of data to have yourself armed with when you're evaluating gee whiz or surprising findings in the published literature, and you're looking at kind of sample sizes there. Okay, so that's another, oh, I forgot I had one more. Smokers think smoking is less likely to kill someone than do non-smokers. Again, you actually need a moderate amount of data to detect that. Again, kind of underscoring this general principle or pattern. Okay, I want to zoom in on the concept of p-hacking for a moment because it's another element that can reduce the trustworthiness of our scientific findings. This has also been called, I'm using this visual, the garden of forking paths. And it's the concept that when we're analyzing our data or conducting our experiments, we have a lot of like small and subtle decision points that we can take. And often what we might see in the published literature is just a publication that reflects the one path through the garden of forking paths that resulted in a finding that worked or a statistically significant finding, even if other paths would have been dead ends or not shown the same effect. And so a study by John and colleagues in 2012 showed that this kind of pursuing the garden of forking paths was actually quite common among psychological scientists. And I would suggest probably you would see similar rates in these other kind of neighboring fields that show similar problems with replicability. So things like not reporting all the measures that were used in a study, peeking at the results and then deciding whether or not to collect more data, conducting a series of studies but only reporting those that work. These aren't like, in the past, these haven't been rare behaviors among psychological scientists. They're actually relatively normative and quite common. The one that shows kind of a low response rate is, of course, outright fraud or falsifying data. And so it's just another cause for concern that perhaps the published literature presents an incomplete, unrealistic, and warped sense of the scientific reality kind of underlying published findings. I was at a conference when this study was presented. It was in San Diego at SPSP. And this led to some pretty heated discussion among the psychologists in attendance. This starts to get into some pretty contentious territory, perhaps not surprisingly. And it's kind of been interesting outside of some of these data just to kind of see how negative some of these debates can turn. It's a really interesting, I mean, it's human beings involved, so it's perhaps not surprising, but I've been able to see that kind of contentious theme up close. Okay, another problem is this idea of harking or hypothesizing after the results are known. So it could be related to the p-hacking problem we just discussed. I think this is best demonstrated in kind of a nice illuminating cartoon. So here we have the king. He's shooting arrows at the wall. And what we can see demonstrated in the cartoon or the drawing is that the arrows are kind of going all over the place. But of course, the assistant is just going up with the paint can and paintbrush and drawing the bullseye on after the shots have been taken. Of course, we wouldn't conclude from this that the king is an excellent archer or has great marksmanship. We can see that something else is going on here. So the parallel that Norb Kerr kind of pointed out in the late 90s is that if we conduct our studies and then build our narratives after the fact, or kind of build predictions and hypotheses into the paper in this reverse time course, that essentially we're drawing the bullseyes after the fact, right? And it's going to weaken our confidence in those findings that they could be replicated or that they're robust. And I think it's nicely illustrated here in this cartoon. Okay. The real source subject that is often avoided, but I think is a rarity relative to some of those other problems in the scientific process that we've discussed already, is outright fraud. But I think it's worth discussing in a conversation of the trustworthiness and trust in science, because we know that it does occur. And although it's rare, it's more common, of course, than we would hope or that we might predict otherwise. So I just have a few kind of high profile examples. One from psychology, Diederik Stoppel was admitted to falsifying whole studies, many studies, essentially just inventing the data. We've seen this in stem cell research, in political science. There are scientists who gain career incentives and prestige and stature and funding based on fraudulent studies, fraudulent findings that are, I would argue, the most kind of gross or disgusting violation of the public trust, and one of the biggest threats to the public trust in science. in Diedrich's case, he has now this kind of successful second chapter because his book about all of his fraud is a bestseller, and has kind of made a handsome amount of income, which I think is kind of interesting, the way he's still kind of derived rewards there. But these are, of course, probably the most troubling kind of violations of public trust. Okay, but all of these, I think, are nicely summarized in this concept that Nozick and colleagues kind of pointed out, that this culture that really is results driven can distort scientific incentives. So what we have is this unfortunate scenario where what's good for science, or public trust in science in particular, would be really high quality, slow, careful, rigorous research that gets published regardless of the outcome. But what's good for a scientist, and what scientists at an individual level are incentivized to do, is to publish a bunch of results, to publish as many, check out this cool thing with acai berry kind of studies that they can, because often we're evaluated in this kind of tally of publications, of citations, and these kind of traditional incentives. So I think that comes with a whole host of problems. So what does it do? It's going to erode public trust in science if scientists are kind of acting in their own best interest, and at times not in the interest of truth, knowledge generation, and science more generally. Oftentimes we see that we might be wasting participants' time and effort if we're just conducting a bunch of studies and only publishing some of them. We haven't fully used this great resource that's being given to us, essentially. There's so much waste when researchers go down what I would call blind alleys. So they're pursuing effects, perhaps some of the operationalizations of ego depletion, that we now know are not very replicable, stable, or robust. Well, people spend their careers chasing those effects. Unbeknownst to them, they're never going to find them. So that's a source of waste and lack of trust in the system. There's been quite a bit of writing, particularly by a science writer I love named Ed Yong, about, he's called it the weaponization, essentially, of some of the replication crisis findings against science. So it really arms, these problems really arm enemies of science with ammunition to tear it down, to erode the trust further, and to argue that we shouldn't have as much support and funding in our work. So it really is a self-defeating kind of process that a field or science in general can find itself in. So the idea is, how can we merge these two circles, right? We want an ecosystem that is more trustworthy and that people can trust at a higher level, because what's best for the science is also what's best for the scientist. So I want to shift just a little bit to discussing some of the more optimistic stuff. I see there's a question. I might wait for the clarifying information before I answer it, though. So I'll see if I'll try to come back to that. Don't let me forget it, though, if at the end I haven't addressed Callista's question. So you all hold me to that over in the chat. Okay, so I discussed this in the last hour, so I'll go over this relatively briefly. But one way that we can increase the trustworthiness of our science is to engage in what's been called open science practices. And this is really just kind of a return to that original or old school, maybe idealized, maybe even kind of a fairy tale version of science in the Nullius and Verba kind of tagline. So we should incentivize researchers to share their data openly so that people can investigate their data analyses, their data collection and curation practices, and potentially detect errors or reproduce their analyses. That can be really productive. It's really good if we can incentivize folks to share their materials so that others can conduct replications of their work. And a real big one is pre-registering our studies so that we commit to our hypotheses before we conduct them. So in a public declaration, we say, here's what I expect to find. And this doesn't allow for harking, and it doesn't allow for the pursuit of analytical flexibility down all the different channels of the garden of forking paths. And I think all of these together in a good system would see more replication attempts so that we can uncover or discover which findings are the most rigorously conducted, most robust, and should have our highest level of trust. So that's kind of one set of avenues to kind of increase the visibility of those behaviors and to really kind of encourage a culture where people do share their data, they share their materials, and they pre-register their hypotheses when they have specific hypotheses. If we kind of zoom out of some of the interventions in psychology and look back at some of the clinical trials work, I think there's some important evidence for why these kind of interventions can be so powerful. So if we look at, I love some of these analyses from the physical sciences. I'm really fascinated by them. Let's just focus on one at a time. So these data are from the National Heart, Lung, and Blood Institute. In the year 2000, they required that clinical trials be registered on clinicaltrials.gov prior to their conduct, and then results were publicly shared so that things were more openly and transparently shared. And you can see that it essentially had an impact on the rates of beneficial findings or statistically significant findings compared to null findings. So if we look at all these crosshatch dots before the registration intervention was implemented, we see a lot of positive findings. Something up with acai berries here for Heart, Lung, and Blood Institute research, and not so many nulls by proportion. But after it was a requirement that people register their predictions on clinicaltrials.gov, we see far more null findings. In some ways, that's problematic, that's troubling, that can be seen as a negative. But what it suggests is that we can have more confidence in those findings that are registered and then do line up with the a priori hypotheses. And so, yes, there's fewer of these benefits being found, but we can have more confidence and place more trust in those. Similarly, these nulls are really important to know. Nothing up with acai berries, nothing up with this substance, nothing up with this intervention, nothing up with this surgical procedure. Those are valid, important contributions to the scientific literature to know things that haven't worked or that don't seem that promising as medical interventions, I would argue. If I had a loved one potentially receiving an intervention demonstrated here, I would want to know about those nulls, right? I would want to know which ones were legit, essentially. And so that can be really powerful. But we also have to make sure that we create a culture of adhering to these policies. You can't make a mountain of new policies and then just think everything is fixed. So a more recent analysis of clinicaltrials.gov registered studies found that almost a third of those published studies changed the primary outcome that they reported from their registration to their final report, potentially suggesting some of this flexibility kind of leaking back in to the system. So I just give this as an example that maybe it's not enough just to have interventions and policies, but we also need kind of a cultural shift to adhere to those policies, to ensure that we're checking up essentially on our stated changes and improvements. Okay, I'm a huge fan of this registration idea, and this has kind of become a publication practice more broadly in recent years. It's called registered reports, so not just on clinical trials, but for all sorts of behavioral research. And in a registered report, instead of having peer review at the end of the process right before you publish, you move peer review up into the design phase. So you get your external expert peer review before you've collected data. And what the journal does when they accept a paper in a registered report format is they commit to the authors that if they follow the protocol written in the draft paper at stage one, at the first stage, analyze the data as they suggest they're going to do it, and essentially just do an okay job at running the study, then they are going to get a publication regardless of the results. There can be other problems in a study that get your paper rejected, but it won't be because you found a null result, essentially. Your paper, nothing up with acai berries, can be published in the registered report format. And so it does a really good job of aligning those two overlapping circles we were talking about, what's good for science and what's good for the scientist. And it allows us to get these traditional incentives even in a pre-registered, pre-committed manner. So I am a huge fan of this. Chris Chambers is kind of the main driving character figure behind these. And I think this is a really important and revolutionary way to publish our work. And I think that the long-term consequences will be really positive for the public trust and perception of science. What are some of its key advantages? Man, when a journal is going to commit beforehand, they get really detail oriented, peer reviewers and editors. So there's a really high bar for very detailed, repeatable methods for people to share data and materials at every stage of the process. There's like a real open science ethos in the registered report world. If you do exploratory analyses, they have to be labeled as such. But what it means is that we get a published literature as consumers and as a public consuming science where we don't have publication bias. We're getting the nulls along with the positives. We don't hark or have hindsight bias when we're evaluating our studies or creating our narratives, and you do away with the selective reporting of research findings. It's still probably the case that a paper that suggests nothing up with acai berries is going to get less attention and less praise, and less press coverage, of course, but at least it will be out there in the publicly shared published literature for all to see. Okay. Another big push that I've been more centrally involved in that I think has promising elements for psychology, the social sciences, and science more generally, but the social sciences are maybe lagging behind the physical sciences in this regard, is what we call team science, or large-scale collaborative efforts where a really widespread team gets together on shared projects and kind of coordinates their expertise. So as Dr. Steltenpohl mentioned in my introduction, and which was the focus of my previous talk, I founded, and for a number of years, I was the first director of this group called the Psychological Science Accelerator, or the PSA, that tried to bring kind of consistent team science approaches to psychology in particular. So we have this large distributed network with sites all around the world, although still heavily represented in North America and Western Europe. All the green dots are data collection locations with researchers that are involved. And instead of all of us kind of pursuing our own research questions completely, we donate, volunteer, or share at least some of our research time, energy, and resources into projects that are conducted worldwide in kind of large-scale collaborative studies. And so what that means is we have large samples, relatively representative and diverse samples, and there's a lot of kind of site-by-site replication built in from the ground up. I want to highlight a couple cool elements I think that are making the PSA somewhat a success in psychology. One is that the PSA welcomes submissions from anyone, so it's not just a small group of leaders that propose and design the studies. Rather, submissions come in a call for studies format. They're then masked or anonymized and evaluated by expert peer reviewers and the whole network. So there's kind of a democratic process to selecting studies. And then they're conducted the world over. And so we get large, stable, robust findings kind of built in initially. Okay, and one of the cool things that we did, I just wanted to give a specific, I just love this project that the PSA did. I was involved early on, but it's just a demonstration of the team science approach can get you a lot of evidence really quickly, even on a rigorous study. So during kind of the peak of the pandemic, we collected data from 21,000 participants at all of these, in all of these countries listed, and found support for like a traditional cognitive reappraisal intervention for the negative emotions and enhancing positive emotions around the pandemic. So if you can get people to reappraise their cognitions or reconstrue them, perhaps by saying something like, it's kind of germane to the talk, but the best scientists in the world are working on this very carefully and seriously. We will have a vaccine soon. It's kind of actually an example from the study that can reduce negative emotion, increase positive emotion during the peak of the pandemic. but it also didn't have negative impact on health behavior. So it didn't make people like laissez-faire about eventually getting the vaccine or wearing their mask or socially distancing. So it's just, I love it. I'm kind of a little fan of the study. I had a small part in it. These projects end up with these massive authorship lists. So one of the big challenges, but also the cool things about team science, is all these people get credit for contributing even a small part to the study. So for me, this is really important. I'm at a small institution. Excuse me. I don't have many research resources, but I can do a little bit on big projects like a face perception study in the PSA or the PSA COVID rapid study. And I get evaluated on peer-reviewed publications, and this counts as one for me, like in my promotion and tenure packet. So for some of us, it can be really beneficial to get involved on these large scale projects. We have to, though, credit really effectively and carefully the right people for doing the right things. So on these projects, you can use this credit taxonomy created by biologists, but that's picking up steam in science more generally, to get really specific about who did what, which I think can also kind of help in evaluating scientists' contributions and work. Okay, good. I think I got some time to like make some conclusions and maybe make a case for some social cultural shifts in how we do our science to increase this trustworthiness, just to kind of wrap things up. And then I think I'll have reserved some good time for some of these questions coming in. Okay, I love this little children's book. It's called Warts and All. And I like looked up what the derivation of the phrase, and I kind of love the saying warts and all. And this is a book about unconditional love for people's quirks and imperfections, which is a good message for children. I think it's also a good message for scientists. Okay, I'm gonna make the case. We should love and share our science, quote unquote, warts and all. What does that mean? It means that we should just accept that even solidly established and well supported, empirically supported phenomena are going to have messy and inconsistent empirical histories. Not every study is going to show the exact same results. In a healthier scientific ecosystem, that's okay. We can live with some inconsistency if we're getting a full and transparent look at the published literature. Loving our science, warts and all, might mean that we conduct fewer but larger, slower, and more careful studies. And we as a community need to accept that that may mean that people get fewer first author publications or traditional incentives for their work. We need to support that. It means that we need to accept people are going to publish more nulls, that not everyone's paper is going to be the arrow with the little bullseye around it, and that those people publishing nulls are still scientists doing good work worthy of our praise if we evaluate their work as rigorous and helpful or informative. It means we're going to see more failed replications, but hopefully also more successful replications. That just needs to become a more normal part of our process. Okay. Finally, we're going to all have to accept that as we share our data and open ourselves up to more scrutiny, we're going to find errors in our own work and others, and we need to be comfortable with that and extend people kindness, patience, and grace. So I want to shift in conclusion to kind of a call to arms, so to speak, for scientists. Okay, I stole the little title from the event. All right, we're a community of scholars. It's easy to complain about incentives and how they warp the scientific process and publications and trust in science. But in many ways, as a community of scholars, we control the incentives. As scientists, we control the incentives. So what can we do? In our evaluation of others for hiring, tenure, and promotion decisions, we can increase our attention to high quality, careful work, regardless of outcome, regardless of flashy positive findings. Perhaps we can evaluate candidates for these career advancement opportunities using what's called an N-best evaluation metric. So instead of just tallying up all their papers and going, oh, wow, 10 papers in science or nature or cell, we can say, why don't we restrict ourselves to looking at their 3 most representative or their 3 best papers? Let's evaluate their work on this small set of really good, careful work. When we are peer reviewers and editors, we get to decide if nulls are worthy of publication, if papers with multiple studies with conflicting and messy results are worthy of publication, and we should accept them, warts and all, and we have the power to change those incentives. We also serve on panels for funding. We can help shape and choose what kind of careful, rigorous, open, and transparent work gets funding. Okay, we also have it incumbent upon ourselves as a community of scholars to create the kind of culture and environment that is going to be best for scientists and science. And I would argue that that has a couple key elements that I've tried to demonstrate in my work and that others have demonstrated even more strongly in some of their interventions in really cool ways. First of all, we should foreground diversity and inclusion. So that's built right into kind of the PSA ethos, at least. Diversity and inclusion are not in opposition to rigor, quality, and excellence. In fact, I would argue the exact opposite, that our work is not rigorous, of the highest quality, and excellent unless it is extremely diverse, representative, and inclusive of all voices, all participants, and all researchers. So when we're thinking of new interventions, we should build that in from the outset. We also have the opportunity to amplify underheard voices. So more and more, I'm saying no to these invitations. As an old, crusty, tenured, established professor, I'm going to try more and more to create space for early career researchers to get these opportunities and to amplify the work that they do. And kind of my last couple points on this front is sometimes like standing up for rigor or acting like you're a serious-minded scientist, for some folks comes along with a negative and conflictual interaction style, which I think is really unproductive. We can take a serious look at each other's work, demand more of each other, but still do it with the utmost kindness. We also need to know that we're working with human beings, and if we're going to accept research, warts and all, we need more patience with our colleagues, and we need to extend them more grace when we detect errors, when they publish fewer studies, and when they publish more nulls, or whatever the case may be. Okay, so be nice to people. That's like rule number one, I would say. So, okay, I'm going to close. This is super cheesy, but I'm going to do it anyways. I almost cut this out. I was interviewed for this cool podcast on Vox, and so I got to make the case there in a way that, like, oh, journalists are really good at like making concluding statements for you, or just framing your quotes just right. So it's incumbent upon us to improve science. So I love this quote they got from me: if you can just marginally improve the way we collect and analyze our data and draw conclusions from them, there are untold future human beings that can benefit from that tiny advance. So when we think about increasing trust in science, I like to take this like long-term future view. We may not fix everything quickly, easily. We may not fix a lot of things, but like when you're doing your work, this question, is science perfect today, should guide you. And the answer is no, of course. And if you can make one tiny incremental improvement, that's extremely worthwhile. That's where you should invest your time. And that's where I think we as a community of scholars should invest our efforts while we're able to. Okay, Dr. Stelton-Pohl, those are my prepared remarks. It looks like maybe I have a couple questions.
Yeah, I'll start off with the one that I think might be a little bit easier to answer. So I'm gonna make a statement, and then I want to hear like to the extent to which you agree with this statement. So
okay.
So would you say that a lot of the focus of a lot of these types of improvements that are being suggested to psychological science, but also other fields, would you say that the aim of those is to put the focus more on the experiment and less on the researchers who run those experiments? Speaking mostly for quantitative work and stuff like that, but like, would you say that the focus is putting it more on the study than it is taking it off of the researcher?
Oh, that's a great question. I don't know to what extent the interventions I've described here directly try to get at that issue, but I would say it is also an extremely important one. A lot of the perverse kind of incentives and negative feedback loops we get in do have to do with, like, I don't know if issues of like ego or reputation or people being really identified with their specific work. I think that can create kind of a defensive posture at times. I'm definitely guilty of this myself as well. It's hard to like take criticism of your work and not take it personally. So what I would agree strongly with is, to the extent that we can decouple those things, the person and the finding, that's going to be productive. To the extent that we can focus on the evidence, the data, that's going to be more productive than arguments over whose model is correct, whose findings are standing up more to the test of time. I think we do want to focus it more at the level of the work and not at the level of the individual. I'm saying all this kind of knowing, though, also in my mind, just how difficult that is. And that's probably that's a lofty aspiration, but I think it's one that, yeah, would be really productive. Okay, hopefully I've answered that. Oh, that was from Callista. Yeah.
Mhm.
Great question. Yeah, cool.
Yeah, and we've got another one that's a little bit more of a comment, so I'm going to turn it into more of a question. So, you talked a little bit about, different influences and different incentive structures, right, that can influence the way that people do their research. We also know, one of the points that you brought up was like these issues with replicability and also trustworthiness and all of that can influence our ways of getting funding. And so we do know that throughout the United States, investment in higher education has gone down in some states like Indiana faster than others. So there's a comment here about public's lack of trust in science. To what extent that might deal with accuracy or replication, and what it might also extend to things like class interest, general skepticism of institutional authority, and kind of the influence of a lot of different corporations historically, like tobacco companies, fossil fuel companies, especially with lung cancer research and climate change research,
Yeah.
respectively. So I was wondering if you could comment on that a little bit, about the influence of those kinds of forces as well, on research trust and trustworthiness.
Yeah, this is great, William. I'm seeing more of your comment, and it's really connecting for me, and it's really astute. Yeah, and I would say that the points you're making in this comment about these external forces and that leading to really reasonable or realistic lack of trust in some scientific fields or published findings is actually really consistent with some of the arguments I was making, that often what we see in those cases is egregious selective reporting or egregious analytical flexibility, so that results consistently line up with the commercial interest of, say, the funder behind a study, or the political interest of a powerful group that's investing time, energy, or support into a study. And so I would argue that where possible, as scientists, we should just set a better example. It's probably easier for us to criticize, say, big tobacco when they selectively report data, if as a community of scholars we demonstrate a better method and model. And it also just shows a specific mechanism by which we can evaluate their work. So I think like the preclinical cancer biology work is a great example where, as you suggest, people have huge commercial interests, and those companies may not be particularly driven by public health interests, but rather by financial interests. But if we have a scientific ecosystem where we can expect and demand rigorous registration of clinical work, well, then at least we get the full picture, and we can evaluate evidence with all of the data that's available. So I don't know, hopefully that kind of, I think that you probably share a lot of, I think we probably share a lot of thoughts on this, it looks like, and you've just kind of thought about it from a different angle. So I appreciate that.
And Will, if there's a follow-up or if I didn't cover that, yeah, it feels like scientists are often adverse to being political especially when the situation may call for it.
Oh yeah, this kind of gets at the idea that scientists are humans, right? So of course we bring to bear all our own kind of perspectives and biases on the work that we do. In fact, some scientists would argue that we shouldn't be apolitical, that there's a lot of room for the scientist activist, because at times we're best positioned to kind of make strong cases on issues that are political or contentious. If that's the case, we're going to best be able to do that standing on rigorous, legitimate, and transparently reported work. So that's going to kind of improve our position there, I think.
Getting some
Thanks,
agreements.
yeah, I love it.
If folks have other questions that they'd like to ask or comments that they'd like to make, feel free to use the chat or to use the Q&A function. I would say, aside from the PSA, and I guess I should also maybe say registered reports, what are you maybe most excited about in terms of the changes that you've seen over the last, I don't know, decade or so?
I think this might just be, my answer might be colored by just like very recent themes in like open science, but I'm really heartened by really strong expressions of support for early career researchers when they're subjected to like nasty behavior by senior researchers. So like I was saying, open science can get really contentious. Replication issues can become really combative and conflictual. And I think I'm seeing like a tide turn in the next generation of scientists where some of these interventions or these reforms are just kind of standard practice for them. And that allows them to take a posture of, hey, we're all human. We all are going to detect errors in our own work. People are going to point out shortcomings, but let's do it in a constructive, collaborative, and kind manner. Maybe I'm being too optimistic there, but I do see kind of more pushback against some of the more kind of like toxic or more bullying forces in science that historically have held so much power and kind of like punched down at less powerful researchers. So I don't know. Am I being too optimistic? I think I see a wave of kind of more positive interaction and criticism. And that's been one of my favorite things to see as I kind of step back a little bit and let others lead the charge.
Yeah. I don't know if that was actually a question towards me, if you were just kind of musing aloud, but I do think I see more change around that. There seems to be less acceptance of harassment, bullying, that kind of stuff within academia, at least in some spaces, and so that's nice to see folks moving the culture in that way.
But at the same time, a lot of people are leaving.
Yeah.
And we're losing a lot of good people because that change is too slow, I think. So even though I have this kind of optimistic frame on it, it's an urgent issue, and we need to be as kind of welcoming and kind as possible so that we keep as many promising minds in the field as possible.
I think I'll ask our last question, unless other folks come in. What advice would you give to an undergraduate student who's thinking about maybe doing research for their career, or thinking, of going to graduate school where they're probably going to be expected to do research? What are some things that you might recommend that an undergraduate student think about now before they head off to grad school?
Yeah, that's a great question. Luckily, I'm kind of like armed to answer it because I don't have grad students. I work directly with undergrads. And so this is kind of part of my standard practice. And so I can answer based on my experience with my students who have been successful kind of at the next level, going into either industry research or PhD or master's level graduate programs. I think it's really powerful on your research experience portion of your CV to be able to pair research experience with the faculty you have close at hand. So you can do like really deep work with them. And I think that's really important and powerful for your materials or your marketability at the next step. But these larger projects end up being, I think, really impressive to evaluators of graduate applicants, but maybe even more so employers. So what I see my students going into like industry research, is I think employers are less impressed by, oh, you and your professor did this really cool study in this really niche area, which is awesome, but I can't wrap my mind around it, versus, holy cow, you were one of 200 people on this study with 20,000 participants that the results are being shared all around the world. And I'm not trying to say that one's better or one's worse, but rather I would urge undergrads to get involved in these big projects because I think they pair really well with like the deeper, slower kind of work one-on-one with faculty. So at least that's been my experience with my students. I think it's pretty impressive to employers and graduate programs. Even if you're a little bit player and you just make a tiny contribution, it's cool to show that you can contribute to a larger team, to a bigger project, and kind of handle that responsibility. So that was really like practical advice version. I feel a little cynical talking about like gaming the career side of it, but that's an important part of this as well for the undergrads. So.
All right. Thank you
Cool.
so much. We've got some thank yous in the chat. Thank you
Yeah.
all for coming. It's been really exciting to talk about open science and stuff with the USI community. Thank you to everyone who asked questions and had comments. And yeah, have a great night. And there's an additional question if you'd like to answer, Chris. Would you agree that the quote that the scholar must ultimately choose between serving truth and justice or power and privilege?
Oh my gosh. No, I reject this. We need to create a scientific system where the two are one and the same. How about that? That's my little thought-provoking, off-the-cuff response to William. I think he's egging me on. You can give William my email address.
I can do that.
Yeah, that would be awesome. It seems like we could have some lively back and forth. So, yeah.
All right. Thank you all for
Cool.
coming.
Thank you.